This video features the SAA Pilot client application built by Luciad. The application is built using a number of OGC standards-based components available in the Luciad Map software suite. The use of OGC standards enabled us to reuse the Luciad Map COTS components, which reduced overall development time and cost. Through a number of use cases, the application demonstrates the use of special activity airspace data in an OGC web services environment. We will first enable an appropriate background layer. The background consists of a VFR chart originally provided by the FAA as a number of disparate images for various U.S. regions. Using our Luciad Fusion product, we transformed these images into a single coherent layer and made it available through an OGC web map service. We will now demonstrate how the application can be used to browse SAA data through an OGC web feature service. All available web services are shown in a toolbar. We select one of the WFS services to retrieve SAA data for the current view. The styling of the SAA data is done through OGC's SLD styling language. This allows advanced styling options and easy sharing of styles between applications. By default, we use a red hatching pattern on most of the airspaces, indicating that they are not active. By selecting one of the airspaces, a balloon pops up showing all available information. For example, a user can consult at what time the airspace is available for activation. Additionally, the application labels the airspaces so we can more easily see the most important information. The application also allows to change the SAA style and take other SAA information into account. During the project, various styles have been defined and made available through an OGC registry service, which we can access in the application. For instance, a style that colors the airspace is based on the type of SAA. The red one here is a military operation area, while the blue ones are restricted areas. Another style colors the airspaces based on the time remaining before activation. As we drag the time slider, the airspace color changes. For example, airspaces that will not be activated have a gray color, while airspaces that are already active are red. To get a better view on the shape and height of an airspace, we can also switch to full 3D environment. As you can see, the styling is applied in the same way as in 2D. We can change the camera position to get a better view of the airspace shape. The application also supports basic flight planning capabilities to demonstrate interaction with the SAA data. In our scenario, we want to plan a flight from Chicago to LA. We draw the flight path using a tool that automatically enables simulation of the flight. Using this flight path, we can now use an OGC distance filter offered by the WFS to retrieve all airspaces that may affect our flight. To remain up to date, we subscribe to an event service that notifies us whenever a NOTAM is published for one of the airspaces. We use the time-dependent styling to simulate our flight. To see which airspace activations affect our flight, we zoom in on the flight time interval. We can now see that although the flight plan crosses an SAA, it is not active during our flight. During the course of the flight, a digital NOTAM event notifies us that one of the airspaces is scheduled for activation. We zoom in on the relevant airspace and evaluate our flight path. This shows that replanning is required because the activated airspace affects our flight path during the time of the flight. This video demonstrated the access, filtering, and portrayal of SAA information in an OGC standards-based environment. Through a set of use cases, we tried to show how these standards can be combined to support flight planning operations.